Alright guys, so we are diving into 7.3, which is all about volume as an integral. We're finally starting to really start using some application with these integrals. We spend so much time trying to just simply evaluate them, but it's with good faith. You kind of have to, right? You got to think to yourself as to how am I supposed to actually figure out application if I don't know how to evaluate them. And so that's what we're continuing to look at in 7.3, and our goals of this video are to understand volume as an integral using cross sections and areas. And within this video, you're going to find a step-by-step scenario as to how to go about finding volume using what we call the slicing method. But I have this first diagram on the screen because I want you to think just for a second about how do you actually find volume. And now, think back to geometry. I know it's in geometry because I teach it as well too, and I'm in the process of doing it with my geometry students as well as the time of this video being filmed. But think about what volume is. Volume, kind of in non-math related terms, is how much stuff can you fit into a solid, right? But really what volume is the sum of all of the cross sections and that area that cross section creates. So here's what I mean. Like, think about it. As this kind of funky looking base shape that we have on the screen right now, if you continue to slice this figure here and here and here and so on and so forth, and all these different slices, you get the same face that you have down at the base, right? And the area of this figure right here is going to end up being the same as you travel down to the other base. So however many cross sections that you have from a point to another point will be your total volume that you have. And so that is what we're going to be looking at in this concept. And so we're going to go ahead and find these areas of the base to figure out what the area of the cross section will be as it goes from a point to another point. So let's take a look. How to go ahead and solve for volume by what we call the slicing method. So first and foremost, you want to sketch the solid. And I'm not no artist. I am not even close to an artist. So most of the things you'll see, I will have on the screen for you because it would be a train wreck to watch me try to draw these. But what you want to think about is once you sketch a solid that is given to you in description, is think about what a typical slice or a cross section would be for it. And then what you want to do is you want to find an area formula for a cross section. Is the cross section going to be a triangle? Is the cross section going to be a square? Will it be a rectangle? Will it be a circle, right? So you're going to have to remember some of these area formulas from geometry. And then we want to find the limits of integration. What is the interval that we are going to be trying to find this volume over? And then finally, we will integrate the formula with respects to x and the limits of integration. So let's take a look at the first example. It says a pyramid 3 meters high has a congruent triangular sides and a square base that is 3 meters on each side. Each cross section of the pyramid is parallel to the base, and of course the base is a square. Find the volume of the pyramid itself. All right, and so before we dive into this, let's kind of summarize what we're looking for. To find the volume, we're finding the area technically of all of these sections that are created. Well, what does that look like? That's the integral over whatever our limits are of our area formula with respects to x. This is what our goal is to find. So that's how we can find the volume of a solid here. All right, so let's think here. Step 1, sketch it. Well, I kind of have it sketched there for you, so it kind of helps out a little bit. Thinking about this pyramid, all right, its vertex is going to be at the origin. So we see right here, right? Its vertex will be at the origin. its altitude is found from 0 to 3, right? So from 0 to 3, it's 3 feet high. Okay? Think about this cross section. You know, a cross section at whatever point, I don't care what point it is from 0 to 3, we're going to call this point right here x, right? So at any point, I'm going to slice it. If that value is x, to find the area of a square, it would be just simply side squared. Well, the value from 0 to x is x. And so the area formula for the cross section in pink is just technically going to be x squared, side squared. And so our a of x in this case is going to equal x squared. So we need to evaluate this integral of x squared. Now specifically, we want to go ahead and find the integral from 0 to 3. Because think about it, the square goes from 0 to 3, right? From the entire top to the bottom of this pyramid. And so yes, the square changes its size as you go through 0 to 3 or 3 to 0, however you want to think about it. All right, but the good thing is by taking the integral, you are accounting for it from 0 to 3, all those changes that happen from 0 to 3. And so the volume is going to equal the integral from 0 to 3 of x squared. So we all know this is x cubed over 3 evaluated from 0 to 3. And substituting that in, 27 over 3 ends up giving us 9. So 9, in this case, we're dealing with meters cubed. All right, so a pretty basic example to start some things off with. All right, so what I want you guys to do is give a shot of one on your own. All right, and it's actually going to end up being a number 3 in your book. All right, number 3 in your book. So this is number 3 on page 406, on page 406, and you hopefully will end up seeing that your answer will be 16 in the end. All right, so give that one a shot, and then we're on off to the next one.